Hello students, let's continue to talk about our discussions of technical notation and look at some examples. Remember we talked about there are 4 different ways that we can express numbers and simply, we use this idea of speaking the same thing in different languages. The 4 categories we use for technical notation is we have a decimal form, which is a number just written as a number. We have a scientific notation form, which is a number whose coefficient is written between 1 and 10. It's larger than 1 and less than 10, raised to some power of 10. And we have engineering notation, which is a number whose exponent is a multiple of 3. And we have metric prefix, which simply takes this power of 10 and replaces it with a symbol. So I have several examples here that let's take some time to talk about. This first one is 314,567. And we have written this in scientific notation. So we take this number and we turn it into something that is a number that is between 1 and 10. So I have to move my decimal between the 3 and the 1. So one number decimal and then the rest of the number. And then I have to ask myself, how many places did I move that decimal point? And in this case, I moved it 5 spaces. So I had to move my decimal point 1, 2, 3, 4, 5. So that becomes 3.14567. And so what happens is this number, this original decimal form, is it larger or smaller than 1? It's bigger than 1, so what that means that my exponent is going to be a positive 5. We'll do some of these examples in just a second. Now I take this, and if I want to go to the engineering notation form, is I take this decimal form, and I raise this decimal form to some power of 10. So usually what I recommend if you have the decimal form is this is sort of becomes our fiduciary or starting point. The 3.14569 is we want to write a number between 1 and 1,000 for our coefficient. So I would move the decimal point 3 spaces. If I moved it 6, it becomes something less than 1. So I simply move it 3 spaces and it becomes 314.567 times 10 to the third, because I moved it 3 spaces. This number is larger than 1, so my decimal is going to be a positive 3. And then there are some charts that are available to you in a handout, and it tells you what these different prefixes are. You need to pretty much commit these to memory. This will not take very long, but 10 to the 3 is a kilo. So that's how we do it here. Now let's talk about a number smaller than 1, and that's this next number here. We're looking at this number here, this 0.04372. So I'm going to write this number in scientific form as a number between 1 and 10, larger than 1, less than 10, raised to some power of 10. And this becomes 4.372 times 10 to the minus 2. And the way we know it becomes a minus 2 is because I moved this decimal point 1, 2 to get a number that was larger than 1, or the decimal point in a significant digit that is a 4. This is between 4 and 3, so this becomes 4.372 times 10 to the minus 2. Now I'll come back to this number, and now I'll start moving this decimal point in multiples of 3. So I'll go from this placeholder to 3, it becomes 0.72. I moved it 3 spaces, so it's a 10, and it becomes a minus because this number is smaller than 1. Remember, our base number and reference number is 1. And now I can take this power of 10, 10 to the minus 3, and replace it with a small lowercase m for milli, and that becomes 47 or 43.7 milli. So there's several different examples here for you to peruse and to practice with. And let's take a look at a number we have here. Let's say that my number is 379. Let me take a look here, got a peek. 500. So this is 379,500. So this would be my decimal form. That's my decimal form. So now I need to write this in scientific notation. The place in practice that I've experienced, and the only time that scientific notation is used primarily is in research, medical and scientific research. They put all these numbers in this format, scientific notation, so it translates from whatever country the researcher comes from, as they realize that it's in scientific notation, and they can convert it to the appropriate format that works for them. So research, you will see scientific notation used in physics and chemistry and medical research. So medical academic and scientific research use scientific notation. So I have to write this number between 1 and 10. So 3.795. These are just placeholders, so I'm not going to put those zeros down there, times 10. And if this was my starting point at that, where my decimal point started, I moved it, there's 3 spaces and 2 more, so I moved it 5 spaces. And this would be a positive 5 because this number is larger than 1. Now let's take this same idea and let's go to engineering notation. And remember, this engineering notation is the power of 10 raised to some multiple of 3, okay? So this exponent is going to be a multiple of 3. So I'm moving this decimal point from the original decimal format in units of 3. So there's 3 there. This would be 6 if I moved it in front of the 3 there. And if I move it in front of the 3 here, make that so this number becomes less than 1. So I'm going to write this number as 379.5. So I moved it in groups of 3. If I move it 6, it becomes smaller than I want it to be. So 379.5 times 10 to the third. Okay. And now I'm going to take this power of 10 and look at my chart or what I've memorized and realize that that is a kilo, and the kilo symbol is a capital K. So this in a metric prefix, and I'll just put prefix here. In a metric prefix, we're going to write this number simply as 379.5 K. There's the K for you. And so this is a couple examples that we'll look in scientific notation. And I'll show you how you can use your calculator to help maybe confirm some of the answers you have and understand how that works.